Okay, so as I was saying, anytime you are drawing a graph, and you realize that your graph is moving this way, it should tell you that your graph is a linear graph. This is what that is okay. And when it's going that direction, that your A is what is negative. So when you find your gradient of the line or of a straight line, you realize that gradient is empty. You know that graph will not go this way, but rather will not go this way, but rather go which way? This way. So anytime you've been given a linear function to plot, but a linear function to plot with, they can give you a linear function as y is equal to what? 2x plus 3. And they will tell you plot a linear graph with it. Then they'll give you a range. So say greater than or less than, so x equals to the right hand side -6 and the right 6. This is telling me that it's -6, -5, -4, -3, up to +6. So this is going to be your the range you are going to plot the graph with. Anytime you are given a linear equation, what your graph with, well, realize that this, which represents your gradient, is positive. You should know that this is how your graph is going to go. After plotting a graph, this is how your graph is going to go. But when you realize that this is negative, you know that this is how your graph is going to go. It's going to go this way, you know. So from left to right, and then from right to left. From left to right is positive, from right to left, negative. So that is for a linear, the linear equation. So we have some examples here. So you have to tell if the following linear function will have a positive gradient or a negative gradient. And I believe this one is so obvious. And then you should be able to, figure a way out through this. So, so for the first one, is this graph a linear function? Is this linear function a positive one or a negative one? The first one, f of x is equal to -x plus 7. Can we say it's a positive? Can we say it has a positive gradient? Vanessa,
That is, it has a negative gradient.
it has a negative gradient too. So this particular one will have a negative gradient, right? Okay.
Yeah.
So that will be it for the linear function. So the linear function is one of the easiest functions that you can learn or you can understand because it's not really complicated. All that you have to know from your linear graphing you did in JHS, you have to know that once you get every line before you can draw a line, there has to be 2 points, right? So let's say if there should be a point here and there should be a point there, and those points must have what coordinates. So if this is let's say A will be, let's say 2, 3, and let's say B will be say 2, 4. So anywhere I draw a line must always have 2 points, point A and then point B, 3 points. So this one will form a straight line. Now, with this, you can find the gradient of the line, right? You know that the gradient of the line, which is m is equal to what? Y2 minus 1 over x2 minus x1. I believe you are familiar with this formula, right?
Yes, please.
Good. So this one will give you the gradient of the line. And then the equation of the line is y is equal to mx plus c. And then your c becomes your constant. So if to use this scenario, this is a linear equation, right? This also can be a linear function. The moment we bring f of x is equal to what? Ax plus b. So when we are given this, they ask us to find the equation of these 2 points or the equation of the line that forms these 2 points. First of all, we are going to apply the y2 minus y1 over x2 minus x1 to find our what? Our gradient. So our gradient is going to what? To our gradient, which is m, we go to y2. So let's give this x1, y1. Let's give this to y2. Our our um, our gradient is y2, which is 4, minus y1, which is 3, divided by x2, which is 2, minus x1. Okay, so x1 to here is 2. Okay, so let's make it 4, which is what? 4. Good. So here, what is going to be 1 over negative 2, right? So it means our gradient is minus half. All right, y minus or minus 0.5. Okay, because this is 1 over 1 negative 2. So that will be our gradient. So now we now have our m, which is our gradient. We can now come and find our constant, which is a c, right? So we can pick any of the coordinates, right? And then use any of the coordinates to fit into our x and our y. Let's choose b. So when we choose coordinate b, let's coordinate b 2 and then 4. Using the equation y is equal to mx plus c, we can say our y will be 4 equal to our m, which we've already found as our gradient to be what? Half, right? So minus half. And then our x, what is our x? Our x is 2 plus our c. So in it, we are finding it, right? So what is it going to be? Yes, sir. So tell me the final one. Okay, so let's just solve it. 4 equals to minus y plus c. So c will be equal to what? 4 plus 1, right? And c will be equal to what? 5. So now our c is 5. You get the point. So now we've gotten our c to be 5, which is our constant to be 5. And then we know our m, which is our gradient to be what? To just half. So now we can now fit this into our equation. The equation of a line is y equals to our m minus half x plus what is our c? 5. Get the point. Because our equation of this particular line. You get the point. And you can see straight that from this line, this is our m, which is our gradient, which is equal to what? Minus half. And then this is our constant. Right? And this, we can see that when we draw a graph using this what? When we draw a graph using this particular linear function, how would the graph go? Will the graph go like this? Or will the graph go like this? So let's name it A or B. Will the graph go the A way or the B way? Hello? Elsie. Elsie.
Say,
Yeah. How will the graph go? Will it go the A way or the B way? The direction of the graph. Will it move from left to right or from right to left?
say please, I just joined.
Oh, okay. Nicer.
Please, we go in the direction of B.
Again. Come again.
That is in the direction of B.
Okay. So watch you. Look at this. Look at this one. Look at the graphical representation of the linear function. You see how it moves. When A is positive, it moves this way. When A is negative, it moves this way. Now look at this function. A, this over here, this one that I've circled, the negative 1 over 2 is A. Now realize that it's negative. We're going to go this way. Graph is going to go this way. You get the point. We're going to go this way. So it means anytime I plot a graph with this particular function, I'm expected to see graph moving in this particular direction. Are you getting the point? Hello, are you getting the point?
Yes, please.
Okay, so this is just linear function, and I believe for linear function, it's GHS, which is like, or use something similar like this in elective math, but you've done this in GHS. So those who just joined us, we're talking about what? Polynomial function. And said in the polynomial function, we linear function, we have the quadratic function, then we have the cubic function. Person who just joined us as left. Wow. So that's what I'll say, linear function, quadratic function, then cubic function. For the linear function, we are talking about straight lines. Straight line. Okay, straight line. So where I draw, you know that anywhere point I can form a straight line. So I draw a point here, and I draw another point here. When I take a ruler, I will form a straight line. So for linear function, we are talking about linear straight line, quadratic function. Then we have the cubic function. And I told you that for the linear function, this is how it's expressed. F of x is equal to ax plus b. I told you that it's the same as the linear equation. There are some similarities. The linear equation is y is equal to what? Mx plus c. And I told you that there is a difference between an equation and what? Function. You get the point. And I told you that this is a graphical representation of the linear function. Anytime you see a linear graph that is going this way from left to right, it's a positive linear graph, or when it has the A be positive. And when I talk about A, you know what the A in this particular context is the A. Is the positive. If you see it's going this way, it means the A is what? The A which also represents the grade as what? Is negative. So that is basically what the linear function, the linear equation is. And I give an example that anytime you are giving like the coordinates that form the straight line, they are basically coordinates that forms the straight line. And with these coordinates, you can use it to find the equation of the line. You get the point. An equation of a line is stated as what y2 minus y1 divided by x2 minus x1. And the gradient of the line is y minus y1 over x2 minus x1. And the equation of the line is y is equal to mx plus c. You get the point. So first of all, before we can find the equation of the line, we have to first find what m is and what c is, because these are the missing gaps, right? The c is the constant, the m is the gradient. Now, y is equal to m is equal to y2 minus y1 over x2 minus y1. What do we mean? We look at the coordinates. This is y2, and this is y1. We substitute in the values for the coordinate to the equation of the gradient of a line. And then this was what we had. We had the gradient to be minus 1 over 2 or minus half. Now that we've gotten this, we will come and substitute this into the equation. We will pick one of the what? Of the points. It could be A, it could be B. Then we will substitute the values into this, right? So wherever y is, we put it there. Wherever x is, we put it there. And of course, we already found our m. We'll put it there. We'll substitute. Then it will be left with our c. So after finding the c, this was what we had. We had c to be 5. So now we have our m, which is this. And then we have our c, which is this. So with the equation y is equal to mx plus c, we can come and substitute c to where c belongs, and then m to where m belongs. So we can now have our equation of the line, which is this. Which is also our function, this line. Do you get the point? Hello?
Hello, sir.
Okay. Vanessa, can you hear me?
Yes, please.
Okay. So I'm coming to give you a question. You first of all, okay, so let me give you this question. I'm familiar with all this question. Um, so this is a so this is A, this is B. I'm giving this to be 1, 3, and this to be 2, 5. So this is the point, right? So you have to find the gradients of the line, find the gradients find the equation of the line. And then the last one determines if the equation will be positive uh, or negative. Okay. So I'm just giving you 5 minutes to solve this question.
Mm.
My God, Vanessa is done. All right. Ella, you went offline. Ella, can you hear me? Okay. So let's solve it
Yes,
together.
sir.
Okay. Ella, have you
Having
tried your
some
handwork?
network problems.
Come again. You're having a network issue. I can even hear from your voice. It's like there are glitches. Okay. Try and move to a place where it is a little bit okay. Okay. Elsie,
Sir,
have you tried your hands on the work?
please some.
Come again. Have you tried your
Sir,
hands on the
please
work?
some.
I can hear you. You are done.
Sir, please some.
Now, okay. Okay. So let's solve the work. So basically, we've been asked to find the gradient of the line. So sometimes you might not see the gradient of the line. You might see gradients of the function. Don't be confused. Okay. Okay. So I always tell you that the equation, there's a slight difference between an equation and a function. Okay. So let's say a function is like two. So let's say let me explain the difference between a function and an equation. So if you have this ax plus b, then have y is equal to mx plus c. Now, when we say a function, this means that whatever I put here in this function is going to have a reflection here. You get the point? Whatever I put here in this function is going to have a reflection here. So if I have a function like, let's say, f of x is equal to 3x plus 5, when I put 5, imagine that that's why we call it a function. It's like a machine that when you put something inside, it's going to be processed. So when I put 5 inside, it means wherever I see x in this particular function, there has to be some 5 here, right? So when I put 5 in this function, it has to give me a result, right? And that result, what is it? Is going to be what? 3 into bracket 5 plus 5, which is going to give me 20. So that is what makes this what? A function. I get in the point. Uh-huh. But you see what equation is? Equation is just an equation. It's just something to tell us or to represent that this thing is a linear equation. So y is equal to mx plus c. That's an equation. They are similar, but they are not the same. They are so close to each other. And they can be used interchangeably in math, but they are not the same. Okay. So now let's solve the work. So the gradient of the line, find the gradient of the line. So first of all, we have to know our coordinates. So we'll state our coordinates. A is what? 1, 3. And then we'll state B is what? Is 2, 5. Then what is the equation? What is the gradient? Gradient, which is also known as M, is what? Is y2 minus y1 over x2 minus x1. It's up to us to label it. So we'll make this one x1, x2, y1, y2, and then we are going to go accordingly. Y2, which is 5, minus y1, which is 3, over x2, which is 2, minus x1, which is 1. It is going to be what? 2 over 1. And 2 over 1 is 2. So our gradient here is 2. So our gradient, which is m here, will be equal to 2. Now, next thing is for us to find the equation of a line. We know the equation of a line is what? Y is equal to mx plus what? Plus c. But our gradient is being found, right? So m is already what? 2. So now it's up to us to find our C. So to find our C, we can pick any of the traits. It could be A, it could be B, to represent our X and then Y. So which one should we pick? I think A will be the easiest, right? So let's pick the A, the coordinate A, which is 1. Since wherever we see X in this equation, we put 1 there. Wherever we see Y in the equation, we put 3. So now we'll have Y, which is 3, equal to M, which is our 2, which is our 2, M, which is our 2, X, which is our M is our 2, right? X, which is our 1, plus C, we don't know, so C. So now we have 3 is equal to what? 2 plus C. And then we get a C equal to 3 minus. This one is basic linear equation, so you should know. And then C is equal to, so we have our M to be 2C equal to 1. Now with that, we can use it to fit into the equation, get our equation of a line. So what are we going to get? We are going to get Y is equal to what is uh our M is so 2x plus is what? Is 1. So let's see. Next time you had this right, and then you had all right. Okay, so it's a positive graph. Why? Because the grade is positive. So anytime I draw a graph like this, how do I expect it to go? I expect the graph to go this way. So when I plot the coordinates, I expect the graph to go this way. Okay. So we can basically plot a graph in this. So let me shift my work to F1 for you to see how it's going to be done. Okay. So our function of what was y equal to, okay, so let me look at it. X plus 1. Okay. So y equal to 2x plus 1. Okay. So let's just bring our x coordinates and y coordinates. So let's just use 1 to 3. So 0, 1, 2, 3, 4, 5. So this will be our x. Then our y. So our y will be the function.
I'm not trying to decide the rest of your life and how it turns out.
What was the function? Come on, I just want to show you that it's going to be a linear graph. Once you plot the graph, uh, 2x1, okay. So 2, 1, 1. Okay. So we can just put this. And then plot a linear graph with this. Let's see how we can plot a linear graph with this. How you doing? How you doing, Aga? So, you hear me? So now realize that it's a positive graph. Now you can see the positive graph. It's moving from this side to this side, right? Uh-huh. So this is the this so this is our equation. This is the equation, and this is how the graph will look like when we plot this equation. You could tell that it's a positive graph. Why is it a positive graph? Because the gradient is positive, and it's moving from this direction to that direction. That is what will tell you that it's a positive graph. Now, you take a look at the equation, you realize that the gradient here is positive. So anytime we get a positive gradient, this is how we expect a linear graph to be. Linear means straight line. So when we plot this function or when we plot this equation on a graph sheet, this is how it's supposed to look like. So you have this idea in your head, you can't deviate in an exam because you know that once the gradient is positive, you know how your look like already by default. You know how your graph will look like. You know that your graph will look like this. It will not look like this way. It will look like this. So with that, you have that in your head. Uh-huh. And when you plot your graph, this is how it's going to look like. I hope you can see what I'm showing. LP, Vanessa, Ella.
Please, I'm okay.
Hello,
Hi.
Ella,
Yes, sir.
Vanessa.
Yes, sir.
Can you hear me?
Yes.
Okay. Okay. So basically that is, I know that you can plot a graph like this. Can you plot a linear graph like this? Ella, Ella.
Yes, sir.
Okay. So this is basically it. Now let's go back to our board. So that is so there shouldn't be any way that when you are given a question on linear question, you deviate. On linear equation, you deviate. Nah, it's the cheapest among the polynomial functions. I told you that we have linear equation, we have cubic function, and then we have the quadratic function. Most of the times, the cubic function is interchanged with polynomial. So when your teacher is talking about polynomial, he's talking about the cubic function. Uh-huh. But all these three are the polynomial, are all polynomial functions. Linear, quadratic, cubic. You get the point? That is the topic. And at this topic, you see all these three there. Okay. So that is about the linear function. Now let's move to the next one, the quadratic function. For the quadratic function, we have so much to talk about under the quadratic function. And I know that most of you are familiar with the quadratic function, the quadratic formula, the factorization method, and the difference of two squares method, and all that. Today, we are going to also take a look at the quadratic function. We will plot some graphs, just like how we did for the linear function. So let me just copy the linear function graph and bring it here. So, gotcha. So we have the linear function graph too here. Okay, so this was the work we just did. The graph of the work we just did. Okay, let me copy the coordinates too. One thing you have to know is that mass, when it comes to anything that involves equation and function, you can represent them on a graph. You can represent them on a graph. That is one amazing thing about mathematics. So with the graphs, it gives you more understanding. So this is the graphical representation of what we done so far. So these are the coordinates. So when x was 0, y was 1. When x was 1, y was 3. And that is what we plotted over here nicely. So even with this, we can find our gradient. All right. It's so nice. So it's so amazing. This is our graph. All right. So let's look at quadratic function. Now, we realize that the linear function, we were talking about straight lines, right? The linear function, we were talking about straight lines. Now, here we are going to talk about curved lines, also known as a quadratic function, right? So you have to know the difference between a function and equation, as I've said already. So this is a quadratic function, and this is how a quadratic function looks like. Realize that the linear function was ax plus b, but for the quadratic function, it's ax squared plus bx plus c. So here we have three variables. We have the coefficient of x squared, which is a, coefficient of x, which is b, and then a constant c. Okay. Now, we are come to do something exciting here. I hope you have your calculators with you. Do you have your calculators with you? Because I also teach students how to use the calculator anytime I'm teaching them math. Do you have your calculators with you?
Yes.
Okay. So now you can use the calculator to get this table. You see the table that I've drawn? Do you already know that? So there's a way you can use the calculator to get this table in order to get your coordinates, so that when you are plotting the graph, you not suffer and then go and solve the y values one by one. You just do it on the calculator. It gives you the coordinates straight up. So now, go to the mode. If you have a calculator, punch on the mode. Have you punched on the mode? I don't know how I can share. Let me see. I don't think I'll be able to share my. But have you gone to the mode?
Yes,
Now, when you go to mode, you go to tables. You press 7. Have you pressed 7? Press
yes,
7.
please.
Okay. Have you seen the tables? So you see, have you seen a function? Have you seen a function? You see f of x equal to something, right?
Yes, please.
Good. And you see, like it's blinking. Now it is trying to tell us, it's asking you, the table is asking you, what is your function? In this case, this is our function. What was the final listing we had for this one? Y is equal to 2x plus 1. So the function will be 2x. So punch 2x. I know where, do you know where you can find the x? I believe you know where you can find the x, right?
Yes, please.
So you press alpha, and then on top of the 9, there is some x somewhere. You punch it. I hope you're all following. Vanessa, have you seen it?
Yes, please.
So you punch 2x, right?
Yes, please.
Ella, Elsie.
Yes, sir, we've punched it.
Okay. So now you punch 2x. Now you punch plus 1. Have you punched plus 1? So now you should be having something like this on your calculator. You should be having something like this on your calculator. f of x. Uh-oh, what is happening to my board? Oops. f of x is equal to 2x plus 1. You should have something like that. Do you have something like that? Do you have something like this on your calculator?
Yes, please.
Now press equal to. What do you see at the equal to? When you press equal to, what do you see? Do you see start?
Start. Yes, please.
Exactly. So you see start, right? Good. So the start is trying to tell you where you should start from. So it will depend on where you want to start from, whether you want to start from a negative integer or you want to start from a positive integer. So let's start from a positive integer. So let's start from, let me take a look at what we did. So for the linear function we started from 0, right? So write start 0, then press equal to. Have you pressed equal to? Have you pressed equal to?
Yes, sir.
Good. Then end. Do you see end? Do you see end over there?
Yes, sir.
Now end at 5. So end at 5. Then you press equal to. Then steps. The steps is trying to tell you the intervals that they have to leave in between. So the step, you make it 1. The step, it means when you move from 1, you move to 2, you move from 2, you move to 3. So the steps, make it 1. Then press enter. Now what do you see? What do you see? Someone should describe what he or she sees. Vanessa, what do you see? Vanessa, what do you see?
Yes, please.
Uh-huh.
It looks like there is of X and Y.
Uh-huh. So when x was 0, what was y on your calculator?
Mm.
Tell me again.
I cleared it.
I can't hear you.
It was 1.
1, good. When it was 1, what was it?
3.
Tell me again.
This was 3.
Plus 3, good. When it was 2, what was it?
5.
Exactly. Now, have you seen how easy it is to get your graph? So with this thing that I've shown you, you can put any function in it, whether cubic function, whether quadratic function, whether linear function, in order to get your coordinates to plot your graph. Are you getting the point? So anytime you are giving a work in an exams, and then they ask you to plot a graph, you quickly go here, you put in your function inside, and then you state the steps, how it should start, how it should end, and the interval. The moment you press enter, you get your table. It will show you all your x coordinates, all your y coordinates, and you'll be able to use it to plot your graph. Okay. I hope we've learned something new. I hope we've learned something new.
Yes, please.
Okay. Now let's move to the quadratic equation. So for the quadratic equation, as I said earlier on, or the quadratic function, as I said earlier on, it is expressed as what? F of x is equal to ax squared plus b squared plus c, where a, b, and c are all variables, right? Good. And the a is coefficient of x squared, b is coefficient of x, and c is constant. When I say coefficient of x squared, I believe you understand. When I say coefficient of x squared, it simply means what is in front of x squared. Coefficient of x, what is in front of x? And this is the constant. So when I have 2x plus 3, and I say, what's the coefficient of x? The coefficient of x is 2. When I have 3x squared minus 4, when I say, what's the coefficient of s squared? Coefficient of s squared is 3. So that is what we mean by coefficient. Now, just like the linear graphing, there's also a graphical representation of a quadratic equation. So we have a positive graph. This is how it looks like. The positive one looks like u, and the negative one looks like n. So anytime we plot a quadratic graph that looks like this, it means it's a positive graph. Or a is positive. That's the coefficient of x squared is positive. Anytime we have quadratic graph looking like this, a is negative, which means the coefficient of x squared is what? Is negative. So the moment you see the question, you should know how the graph is going to be, whether it's going to be in the U shape or the N shape. Okay. Okay. Now you are going to help me so that we plot some graphs. Before I explain this area and axis of symmetry and those things, we will do some plotting of quadratic graphs right now using what I've taught you. So I'll give you the quadratic equation. You will use the table mode on your calculator to give me the coordinates. All right. Are you ready for this?
Yes, please.
Okay. Ella, Elsie, and user. I don't know who is called user over here, but I hope you are all ready for this. Okay. So let's start. So as I said earlier on, a quadratic equation must be in this format, or a quadratic function must be in this format, right? Ax squared plus b, x plus c, where a, b, and c are all constants, right? This one is coefficient of x squared, this one is coefficient of x, and this is the constant. Okay, they are all values, a, b, and c, they are all values. So let's see something. So we are going to plot 5 graphs before we continue. We are all going to learn how to plot a quadratic graph, okay? So this is the quadratic equation. You are going to use your calculator to get the table and everything, and that is what we are going to use to plot the graph. So this is number 1, number 2, number 3, number 4, and number 5. So the first one, come in. Okay, so first of all, let's write this one down. Plot to question 1. So you have to plot a graph. Plot a graph of, they can give it to you as a function of the function f of x equals what? Equals x squared minus 4x plus 3. S squared minus 4x plus 3. And they've given you the range. The range is what? -2 less than or equal to x less than or equal to 6. So for -2 less than or equal to x less than or equal to 6. So what does this mean? Who can tell me what this means? What does it mean?
That is the range.
Mhm. So the range, right? So from -2 to what?
Positive.
Okay. So -2 to 6. So we are going to plot this graph first. So now go to your calculator and give me the coordinates. So first of all, you go to mode, you go to table 7. You see something like f of x equal to. Then you punch x squared minus 4x minus 4x plus 3. When you press equal to, they'll give you start from, you use the range that they've given you, -2, and end at, you use 6, the intervals, you make it 1, then tell me the coordinates. So when you're done, you raise up your hand, I call you, you mention the coordinates for me. So let me draw your table. So we have a x coordinates, and then we have a y coordinates. Using the function f of x squared minus 4x plus 3. For the range, -2, x, 6. This is to tell us that here is -2, -3, and -1, 0, 1, 2, 3, 4, 5, 6. Okay, I'm waiting for you. Once you are done, give me the coordinates. And let's use this to plot quadratic graph. Okay. Everybody try your hands on it too. Ella. Ella, can you hear me? LC. LC.
Sir,
Are you paying attention to what we are doing?
sir, please, I keep going on and off, so
As in
I
your
don't know.
network, eh?
Yes.
Okay, I'll go over and don't worry, okay? So let's just finish solving this one, then I'll go over one more time. But make sure that your network doesn't go off, okay?
Okay.
All right. Vanessa, are you working on it?
Yes, please.
Okay. Who is user? Who has his or her name as? Okay.
Okay, sir. Please, it's me,
Oh, okay. Your name.
Akosia.
Oh, okay, okay. Are you following?
Yes.
Okay. So we have this is the quadratic equation. Quadratic function is enough to plot this graph for this range. And I've taught you how to use the calculator to get your values. If you are to use a conventional way, you are going to keep long. And normally they don't really, mark those conventional way you use to get the y values. So just use your calculator, get this fast, and then. Okay. So we are going to plot this wonderful graph. Once you are done, raise up your hand. I'll call you, then you mention the coordinates for the y value. Hello, that's what here.
Yes, sir.
I done.
Yes. I'm
Okay.
still on it.
Okay. Okay. Who is done? I believe most of you have laptops there. You guys can learn how to use Microsoft Excel to plot graphs. It will help you study math well. Most of you have laptops, right? Oh, okay. So yeah, I was actually not asking us to solve the quadratic equation though. I just wanted us to plot the graph using the coordinates that we've been given. Yeah. So the answer is right though. Yeah, the answer is right. But I just want us to get our coordinates to plot the graph. So the question they asked us to solve the quadratic equation. Question 1 says plot a graph of the function f of x is equal to 2 x squared minus 4x plus 3. For x is greater than or equal to -2 and x is less than or equal to 6. And as Vanessa said, this tells us the range through which we are going to what? We are going to plot the graphs within. So from -2 to what? 6 for the x-axis. Okay. So when x was -2, y was what? Vanessa. When x was -2, y was what?
15.
Come again.
15.
Did you say 15? Yes. So 15.
Yes.
So when x was -1, y was what? Elsie. When x was -1, y was what?
Yeah, please. 8.
8. Good. Ella. When x was 0, y was what?
3.
Very good. User. Akosia. User Akosia. When x was 1, y was what? 'So when x was 1, y was 0. Vanessa, when x was 2, y was what?
-1.
Okay. So it means you guys have gotten how it is flowing. Then what again? When x was 3, y was what?
0.
3. When y was what? What is what was 0? And then when x was 4, y was what?
3.
3. When x was 5, y was what?
8.
When x was 6, y was what?
15.
15. Good. Now we are done getting our table. Now it's now time for us to plot our graph. So yeah, looking at this, we know our x coordinates, right? So for our y coordinates, looking at how the value is like, we can make it an interval of 1, right? So 2 centimeters to 1 unit. 2 centimeters to 1 unit, we'll get like 15. Okay. We can also make it 2 centimeters to 2 units. But depending on how you will be able to plot your graph, yeah, your skill will depend on you. If you're not giving the skill in the question, it will depend on you on what skill is suitable. So let's transfer this onto our Excel sheet and let's see how we are going to plot the graph. You're welcome back here. So yeah, it was from -2 to this one. Right? Okay. So let's do this. I'll form a new one. Let's form a new one under this. So we have our x values, and then we have our y value. And the range was given to us as well, from -2 to 6, right? So negative. So let me just from -2 to 6. So -2, -1, 0. So let me just make it 0, 1, 2, 3, 4, 5. Yep, I think. And then let me just use just here. Oops. Oops. Now, after plotting the graph, we will know we are going to find out that we can even solve the quadratic equation from the graph that we are going to get. Six up to 6, right? Now, y coordinates. What was the equation of? So it was s squared minus 4x plus what? Sorry. Okay. Okay. So it means when x for our equation, when x was -12, y will be 15. Okay, then we can use this. To this point. Good. So now we have exactly as we had in our question, right? The table, that's exactly what we had in our table. So now let's plot our graph. Good, good. Now, take a look at this graph. Oh. Let me come here and paste it here. So this is our graph. Okay. So I wish you guys had graph books with you right now. If you have a graph, you can go and grab it. Okay. Copy this. And now let me share this. So this is our graph. Now, if you have a graph sheet, you realize that you see the x variable, the x coordinates. This is the x coordinate. So this is our y coordinate, this is the x, and this is the y, right? So we started plotting when x was -2, y was what? 15. If this is 14, the center will be 15. So this will be our 15. So we'll draw the first line. The second one, when x was -1, y was what? 8. This is our 8. Exactly on point. When x was this is it. Why is it not doing? When x was 0, y was 3. If this is, you realize that for the y, for the y coordinates, the interval was 2 centimeters to 2 units, right? So 2, 0, 2, 4, 6, 8, 10. So when x was 0, y was 3. So this will be 3. Exactly in the middle here. When x was 1, y was what? 0. When x was 2, y was -1. So -1 to come down to the negative side. When x was 3, y was 0. When x was 4, when x was 4, it was 3, right? When x was 5, it was what? It was 8. Can you see where 8 is? When x was 6, it was 15. Can you see where 15 is? We plot our graph. Then you draw, use your freehand sketch to draw your quadratic equation. Can you see it now? Hello?
Yes, please.
Okay. Now, you know that we can use the graph to find the values of x and y. Do you know? If they were to ask us to solve the quadratic equation, we can get the values of x1 and x2. Do you know that? So the values of x1 and x2, you know that every quadratic equation, when we solve, we get two answers, right? X1 and x2. Now, if you look at the graph, we realize that this is the point where the graph touches the x-axis. And this is the point where the same graph touches the x-axis. So here we can say x1 is equal to 1 and x2 is equal to what? 3. So from the graph, we've been able to solve our quadratic equation. We've been able to plot the graph to, well, you get the point? So as we go along, you see that we'll be talking about a lot of things: the minimum point, the maximum point, the point that it divides into 2, and all that. We learn all these things from the graph. So now, can you see your x and then your x1 and x2? Akosia,
Yes, sir.
can you see your answer was right? But you said x1 is 1, x2 is 3. Now, can you see it on the graph?
Yes.
Okay. So it means even if you are finding it difficult to solve the quadratic equation, from your graph, you can get where x1 and x2 is. And now look at it. And you know that from your table, you can know where x1 and x2 is. So from your table, what you do is that you check the y coordinates. From the 0, you point. So this is your first x1. From the other 0, this is your x2. You get a point. Hello?
Yes, please.
Good. So that is a very simple way you can plot your graph. And I'm saying that learn how to use the Excel, Microsoft Excel. I mean, do you have laptops?
Yes,
Do you have
please.
laptops? So
Yes.
learn how to use the Microsoft Excel to create. It makes learning fun, right? You see, I was able to use the Microsoft. I just learned it today. I knew a lot about the Microsoft Excel, but I was just trying to figure out how I'll be able to use it to plot, because I know it can do a lot of things. So I was able to learn how to use the Microsoft Excel to plot quadratic curves, and it's working so nice, making our learning so interactive. I don't need any graph book. I'm just using the graphs here, and it's making the learning so interactive. So you can also learn how to use the Microsoft Excel. Use your laptop, you use the Microsoft Excel, and then you use it to learn how to plot all forms of graph. Okay, so that is it for the quadratic graph. So now try this one. So the first one, we have plot a graph of f of x squared minus 4x plus 3. for x is equal to this. So the second question, I'll tell you, hence, find the value. Okay. So let's go to the second one. Second one, we have draw the graph y is equal to negative x squared plus 2x plus 8. Good. So this is the same. Plot a graph of f of x negative x squared plus 2x plus 2x plus 2x plus 8. So for the range, let me see. Let's use the same range. Let's use the same range. Negative 2 greater than or less than or equal to x, less than or equal to negative 6. So let's use the same range for negative 2, x, 6. Okay. So as we move along, we will look at situations where you use the graph to generate your quadratic function or your quadratic equation. It's also possible. So it's like the reverse of what we are doing. Here, we will be giving the quadratic function. They will use the quadratic function to plot our graph. But we also look at a scenario where we use the graph to plot our quadratic or to create our quadratic function. So do the question 2. The table, when you're done with the table, let me know. And I've showed you a short way to use the table using your calculator. Okay. So try it and let me see. Okay, so Akosia, I can see your message. Okay, okay. All right. The plotting of the graph. So Akosia, do you have your calculator here with you? Akosia, do you have your calculator with you? I want to teach you how an easy way you can use to plot the graph. Of course. Of course.
Yes, sir.
Yeah. Can you hear me?
Yes, sir.
Oh, okay. So for the quadratic equation, we are plotting the graph now. We've not reached the point that we are going to solve them. Okay, that's in using the quadratic formula and the difference of two squares and the factorization method. For now, we are just learning how to plot the graph and then be able to use the graph to identify the minimum values and the maximum values and where they occur and all that. So once we are done with that, then we will shift to how to solve the quadratic equation itself. That one is not going to be, there's not going to be so much graphical work. It's going to be a lot of solving. I get to the point.
Yes.
But do you understand how the graph is plotted? Do you understand how the graph is plotted?
Yes, sir.
Okay. Okay. So the second question. This is the function of f of x is equal to what? Negative x squared plus 2x plus 8 for this range. So let's go. The coordinates. So someone should help me with the coordinates. So for the second one, when x was negative to what was y? For the second one. So let's draw it nicely. So Akotia, you help me with this one, the second question. We are plotting.
Okay.
So we have the x and then the y. So from the question, the range is what? It's -2 to what? To +6. So we have -2, -1, 0, 1, 2, 3, 4, 5, about 4. 6. So the question is, okay, so when x was negative to what was y? So yeah,
Yes, sir.
when x was negative to what was y?
Sir,
Hello?
please, you were showing me the calculator part.
Okay, okay. So do you have your calculator with you now?
Yes.
Okay, now go to mode. Have you gone to mode?
Yes.
Now go to tables. So press 7. Have you pressed 7?
Yes.
Now have you seen the function? Have you seen the function something that over there, f of x equal to something? Have you seen something like f into bracket x equal to?
Yes.
Okay. Now you see that the function there is negative x squared plus 2x plus 8. Have you seen that over there in
Then
the question? As in the question, have you seen that
yes,
the function
yes.
is yes? So you are going to punch the same thing. So you know where to locate x. You press alpha, and then you press the button at the on top of the 9. You can identify your x, right? Let me see if I can. Let me see.
Say,
Yeah, have you seen it? Have you seen your x?
please, I got 4 and -2.
Ah, I'm correct. Hello, I'm sharing some camera. Can you see it? Can you see it?
Say,
Can you see it?
yes, say.
Okay, so it's simple. You see, you go to mode, you press 7, you go to the equation, right? Then you directly punch your what? Negative. There's x. You press the alpha, you press this to get your x, right? And then you press this to get your x squared plus 2x plus 8, right? So just do exactly as I'm showing. Have you done that? Hello?
So say,
Have you done that? Hello?
yes, say.
Okay. Now you press equal to. Have you pressed equal to? Have you pressed equal to? Hello?
Yes, say.
Now to give you some range. So if you've seen start over here, right? So start
Yes.
from here, you write -2 and you press enter. Then it will tell you end at. Then you press 6. Then you press enter. Then here the steps means interval. So the interval we just maintain it as 1. Then you press equal to. It will give you a table, just like the table we have there. So here, the table -2, it means when x was -2, y was 0. When x was -1, y was 5. When x was 0, y was 8. When x was 1, y was 5. When x was 2, y was 8. When x was 3, y was 5. When x was 4, y was 0. When x was 5, y was 7. In that order. Have you been able to, have you gotten that?
Yes.
Now I can shift to my laptop. So now give me the coordinates. So when x was -2, what was y? Akosia. Akosia.
Zero.
Yeah. When x
Zero.
when x was -2, what was y?
0.
0. Okay. When x was -1, what was y?
5.
When x was 0, what was y?
8.
When x was 1, what was y?
5.
When x was 1, it's not
Hey,
negative
wait.
1.
When x was 1, y was 5. Hey, sorry.
Look at it well. 1, 1, 1, 1, 1. What you are mentioning is -1. So from the when it was -1, it was 5. When it was 0, it was 8. When it was 1, it was what?
Hey, I'm coming.
Vanessa, can you hear us?
Yes.
Okay. So once we are done with this one, the remaining 3, I'll give it to you as a homework. Please. I know some of you have graph books around. Use your graph book. Then you plot the quadratic graphs. Because we are going to use them for tomorrow's lesson. We are going to use it to find the minimum value, the maximum value, and all that. Akosia,
Hey.
Elsie, are you with us? Akosia, when x was 1, what was y?
Say, please, I'm doing it again. I had a problem.
But do you will you be able to do it as I showed you on the calculator?
So I'm doing it.
Okay. Adam, if you have any challenges, let me know, okay?
Think I need to.
Come again.
I missed the steps.
Okay, so let me do it again. This one, once you learn it, it's going to help you very, very fast in the exams, especially objectives. Can you see now?
Say.
Okay. So it's simple. You go to mode. You press 7. What was the function? The question. Negative x squared, right? What was it?
Negative x squared.
Negative x squared. Negative x squared.
Say, please hold on.
Plus 2x. Are you getting the point? Plus
Yes.
2x plus 8. So after you finish punching this, you press equal to. They will ask you step. Start from. The range was -2, so you write -2. You press equal to again. They will ask you at end at what? 6. You press equal to. They will ask you for the steps. The steps is the intervals. The intervals is 1. So you maintain the 1. Press equal to. It gives you the range, right? So when x was what? When x was -2, y was 0. When x was -1, y was 5. When x was 0, y was what? X was 0, y was 8. Do you get the point? If you want to return your calculator back to normal, you press mode, you press 1. It's now back to normal.
Say.
Hello?
Please, the part where you get the x.
The part where you oh, okay. So let's start over again. So your 5, your mode, your 7, you get this. Look at this. This one. You press the alpha first, then you press this one. You get the point?
Say, please.
You press this, then you press this. So you press alpha. You see that there is some A here. You press alpha, then you press this to give you your x. So negative x, you bring the negative in front of the x. Right? Then this is your square button. This is your square button. Plus 2, you use the same way. Alpha, your x. Plus 8. Plus 8. Get this. Have you been able to get this?
Yes.
Okay. Now you press enter. It asks you start from where? Start from -2. -2. You end at where? 6. Press enter. Steps 1. Then it gives you the graph, the table. Have you been able to do that? Have you been able to do that? Hello? Okay, so let me switch back to my laptop. It's not even online. Can you hear me, Vanessa and Co?
Yes, please.
Okay. I just want Akoja to get how, because we'll be using this a lot. We'll be using this a lot. The calculator, everybody have to know how to use it. It makes math so easy. But Vanessa, I believe you can do it. Elsie,
Yes, please.
Elsie, what about you?
Sir,
Elsie,
please. Yes.
okay. To be able to, I don't know where Akosia has passed though, but it's the reason why we are here, as in we are stuck behind. So you, Vanessa, let's continue with the coordinates. So when X was 1, what was Y?
Sir, please, 9.
9, good. Elsie, when X was 2, Y was what? Come again. Come again. Elsie. When X was 2, Y was what? So let's continue. Vanessa. I think Elsie, I don't know why they are having network issues. So Vanessa, when X was 2, Y was what?
8.
Good. When X was 3, Y was what?
5.
Good. When X was 4, Y was what?
0.
When X was 5, Y was what?
-7.
-7. Good. And then when it was 6, it was what?
-16.
-16. Yes. So that is for your Y coordinate. So now with this, you can use it to plot your graph, right? Now, so even from the table, I showed you a trick to get the values for what? The values for X, the two values for X. Even from your table, you can tell which values are for X. So here we can see that X1 is what? -2, and X2 is what? 4. True or false? So in order for you to find your X value, one trick that you can use, you look at your Y values. The zeros that are in your Y values, you trace it to the X value. That becomes your first X. Here, you trace it, that becomes your second X. You get the point? So now we can use this to plot our graph. Now, how do you think the graph will be? Looking at the function, would the graph be a U shape or an N shape? Look at the function. Would the graph be a U shape or an N shape? Vanessa?
That is an N shape.
An N shape, because this is negative, right? The coefficient of S squared is negative, so it's going to be an N shape. Now let's see how it's going to be. Let's plot it. Let's plot it fast. Then we can see today I joined very early. Vanessa, I think you also joined very, very early. But the rest didn't join that early. So please, tomorrow, let's come very early. I don't know what's happening to our course here. Let's work. So let's plot this. Agosia, or who is that also?
Yes, then my laptop was low battery.
Okay. So were you able to understand this thing?
Yeah, I got to part 1 and 5.
Sorry again.
and 5 part, where the beginning is 1 and the end is 5.
Yes, the beginning is 1. The beginning, okay, so the beginning, so that 1, you change it to -2. Because in the
Okay.
question, it was -2, right? The range was -2 to 6.
Okay.
In the end, you make it 6. And the interval, you make it 1.
Okay. Negative, I'm coming. Fair.
Hello?
You said I should change the 1 to -2.
Yeah, the interval, yeah. So -2. And the starts from, you change it from into -2. Do that, let me see what you get.
You said I should change the stats, which is 1, to -2.
Yes.
Okay.
Right on. What are you done? You're the one we are waiting for. Hello. Okay. So what you are going to do before tomorrow is that you are going to plot this graph. You are going to plot this graph. This one. You are going to plot this graph. So we've been able to draw the table. Now plot the graph tomorrow. Tomorrow you just take a photograph of it and then you either send it to me or I don't know how you are going to do it too, but I will inspect the graph for this particular table. Okay. Tomorrow we are going to use the graph to find the minimum and the maximum points, the minimum or the maximum points and the points or at which they occur. And this is it, the minimum or the maximum points and the points through which they occur. Then we'll solve the quadratic equations using the factorization method, using the difference of two squares, and using the quadratic formula. Okay. Any question up to this point? Akosia? Vanessa, do you have any question up to this point?
No, please.
Akosia? Elsie, do you have any question up to this point? Elsie too is gone. Akosia, do you have any question up to this point? So please plot the graph and we'll use it. Akosia, I want to hear from you.
Hello, sir.
Yes, can you hear from me?
Yes, now I can hear you.
Okay, were you able to do the calculator work?
Yes, but it got to a point, they said error.
How?
I don't know. I was trying.
Okay. So you know what? Tomorrow evening when we meet, I'll take you through how it's done again because it's something that all of you have to know. That tutorial I just did, and I think some of you have gotten how it is done. I think Vanessa and then Elsie. Yeah. So tomorrow evening, I'll take you through once again how it is done. You have to get yourself conversant with the calculator. Mm. Elective maths is about speed, not just accuracy. If you are accurate and you are slow, you will not be able to do most of your work. So it's a speed work because remember that the final exams you'll be answering like 12, I think 12, is it 12 questions or so? How many questions? Yeah, is it 12? Time we answered about 12 questions or so. So it's a speed work. Time is
Um,
not on your side. So you are
um,
going to, hello.
please, where the start when I entered -2,
Mhm.
and then the end I entered a 6.
Uh-huh.
Then I pressed.
They'll tell you steps. The next thing that will come will be step. That step, you make it one.
Oh, okay,
Yes.
okay, okay.
Now has it come?
I'm doing it.
Okay. So please for emails there, as I'll be teaching you, I'll be teaching you a lot of tricks in the calculator that will help you be very fast.
Okay.
So today,
Sir,
yeah, has it come?
no, I don't. After the -6, then
Uh-huh.
it comes as error.
After the -6.
Yeah.
Okay. So you just so this is how you are going to do it. So first of all, you go to your mode, you go to your 7.
Mm-hmm.
After gotten to the 7, it will take you to the table side, right? The equation side. So the
Mhm.
equation side, you punch your function over there. So in this case, negative x squared, right? Plus
Yes.
2x plus 8. Have you punched that one? Negative x squared plus 2x plus 8. Then you
Yes.
press equal to. Once you press equal to, it will write start.
That, yes.
Then start, you write negative 2. Then you press equal to. Then it will take you to the next place. They'll tell you n.
And
Then you
6.
write 6. Then you press equal to. It will go to a place. They'll write steps. The step it has already the one has already been written there. So you just press equal to.
Oh, okay.
Then a table will be generated.
Okay. The table has come.
Okay, so mention the content in the table. Let me see whether you are right. You did the right thing. So when x was
Negative x
2,
was 0.
uh-huh.
Then
So just tell me when x was negative 2, what was the y coordinate?
0.
Okay.
Then when
Uh-huh.
x was negative 1, y was
Uh-huh.
5.
Okay, that's true. Uh-huh.
Then when x was 0, y was 8.
Okay, that's true. Uh-huh.
When x was 1, y
Mm-hmm.
was 9.
Exactly. Uh-huh.
When x was 2, y
Mm-hmm.
was 8.
Exactly. Uh-huh.
X was 3, y was
Uh-huh.
5.
Okay. Uh-huh.
When x was 4, y
Uh-huh.
was 0.
Exactly. Uh-huh.
When x was 5, y was negative 7.
Exactly. And the last one.
When x was 6, y was negative 16.
Brilliant. So that is it. You now
Okay.
get it.
Yes, sir.
So it is out of this that you are going to use to plot the graph. Do you get the
Oh,
point?
yes.
Good.
Thank you, sir.
You're welcome. So this is what we are going to do the next time we meet. You are going to use the table that we've generated to plot your graph, a quadratic graph. How do you do that? This one, you can make your scale 2 centimeters to 2 units for the y-axis, and then 2 centimeters to 1 unit for the x-axis. So this is how you're. Let me just give you another. I know you have graph books. If you have a graph book, use the graph book. So tomorrow I'll be inspecting that. So this is how your graph is going to be. Here, 0, positive integer. So 1, 2, 3, 4, 5, 6. Yeah, it say up to -2, right? But you can still go ahead and do -1, -2, -3, -4. Can just and then the x, you see, it's up to 16. But your graph, I think the standard graph we have is up to, I think it's up to 10 or so. So here the best option is 2 centimeters to 2 units. So 2, 4, 6, 8, 10, 12, 14, 16. And here -2, -4, -6, -2, -4, -6, -8, -10, -12, -14, -16. So you do it that way, and then you start to plot. When x was what? -2, what was y? Y was 0. So the first point to be here. When x was what? When x was -1, what was y? Y was 5. So -1, y was what? 5. 5 will be somewhere here. So it means you have it here. When x was what? When x was 0, what was y? Y was 8. When x was 0, y was 8. So you have it here. All right. When x was what? So you see that the shape is becoming an N shape, as we said. So when x was what? 1, what was y? Y was 9. When x was 1, y was 9. So it will be somewhere here. When x was 2, y was 8. X was 2, y was 8. So we'll come back here again. When x was 3, y was 5. X was 3, y was 5. It will be somewhere around here. When x was 4, y was 0. X was 4, y was 0. Somewhere around here. When x was 5, it was -7. When x was 6, it was -16. So I'm expecting your graph to be this way. Something like this. Are you getting the point?
Yes.
Good. So this is just a sketch. Once you have your graph sheet, you can do it well. Okay. So
Okay.
I'll be inspecting that tomorrow. I hope you enjoy the lesson.
Yeah.
Okay. So if there are no questions, then I think we have to call it a day.
Okay.
God
Thank
willing,
you.
tomorrow we shall meet.
Bye.
Vanessa,
Hello, sir.
I hope you understood everything.
Yes, please.
Elsie,
Sir.
I hope this is cuckoo for you. I hope you don't have any challenge. Probably the only challenge you have is your network. The only challenge you have is your network. So this is basically it. So today, so far, among all the lessons, today is the easiest. Let me just see. What is coming ahead is a little bit technical than this. So prepare for that too. Tomorrow onwards. All right. Have a wonderful evening. Bye bye.
Bye.